गुड मॉर्निंग। यह हमारी एमएससी फाइनल ऑर्गेनिक केमिस्ट्री की क्लास है। नेम रिएक्शन सीरीज़ में अब तक हम काफ़ी नेम रिएक्शंस कवर कर चुके हैं। जस्ट मैं रिकॉल करके बताता हूँ आपको कौन कौन से नेम रिएक्शंस हमने शुरू से अब तक कवर किए हैं। देखिए, फर्स्ट वी स्टार्टेड विद एल्डोल कंडेंसेशन and we completed aldol condensation in 3 parts, and then Beckmann's rearrangement we completed in 2 parts, then pinacolon rearrangement in 4 parts, then benzylic acid rearrangement in 3 parts, then we did Baeyer-Villiger oxidation in 2 parts, and then we completed Arndt-Estret synthesis again in 2 parts. तो पार्ट्स बताने का मतलब ये था मेरा कि इन वीडियोस को आप लगातार देखेंगे, ऑर्डर में देखेंगे, तभी हमारे लिए बेनिफिशियल होता है। इन नेम रिएक्शन में मैंने मैक्सिमम एग्जांपल्स जो नेट के एग्ज़ाम में क्वेश्चंस बन सकते हैं, सारी एग्जांपल्स इससे कवर की हैं और इनको देख के आप अपनी कॉपी में नोट्स बनाएं। केवल सुने नहीं, इनको बार बार देख के आप इनके नोट्स बना लें, उससे आपका नेम रिएक्शंस काफ़ी कवर हो जाएगा। ओके, आज हम एक बहुत ही इंपॉर्टेंट नेम रिएक्शन पढ़ने वाले हैं, दैट इज़ फेवरिस्की अरेंजमेंट, फेवरिस्की रीअरेंजमेंट। तो व्हाट इज़ फेवरिस्की अरेंजमेंट? देखो क्या होता है इसके अंदर कि हम अल्फ़ा हेलोकीटोन्स लेते हैं और अल्फ़ा हेलोकीटोन्स की रिएक्शन जब हम एल्कोक्साइड से कराते हैं तो एस्टर्स बनते हैं जिसके अंदर की स्केलेटन रीअरेंजमेंट हो जाता है। तो व्हाट यू कैन जस्ट नोट डाउन सिंपल वन वर्ड डेफिनेशन बिकॉज आई वुड नॉट लाइक टू राइट इट हियर, दैट इज़ अल्फ़ा हेलोकीटोन्स on reaction with alkoxide forms esters with rearranged carbon skeleton, and it is called Favorskii rearrangement. That is this. Okay, first see what is the, let us take some basic example for this. Say C6H5CH2 alpha haloketone. So this is the essential condition. It is the alpha haloketone. This position is the alpha position, and when it is treated with alkoxide, carbon ion is formed and this attack. That I will tell you in mechanism. First see how to write down the product. Just eliminate this product. It is eliminated. This group will migrate to this position and alkoxide comes over here. Short of this is, that is this group. This is not a mechanism. This is how to write the product I am telling. This is to be shifted here and alkoxide is to be put over here. That is, we can write ROC double bond O CH2 as such, and this group is coming from this. This is just I have told you how to write down the product of this, and this product formed in this case is the ester. Now see, we are taking the same this. Again, see, take the same example, and in place of alkoxide की जगह अब हम अगर मान लीजिए लेते हैं सोडियम हाइड्रोक्साइड, that is we are doing it in the presence of base, or again say we are doing it in presence of amide base NaNH2, then again same thing. What will happen is this OH group will come over here and this group whole migrates over, halide ion departs. So when OH comes over here, product will be acid. When NH2 comes over here, product will be amide, this group. तो फर्स्ट सी हाउ टू राइट डाउन द प्रोडक्ट। हमेशा पहले मैं ये सिखाता हूँ कि प्रोडक्ट कैसे लिखना है। प्रोडक्ट लिखने के बाद हम मैकेनिज्म देखेंगे, हर एस्पेक्ट इसका देखेंगे, फिर हम इसकी एप्लीकेशन पार्ट्स देखते हैं। ओके, आई होप प्रोडक्ट लिखना आपको आया। अल्फा हेलोकीटोन से अल्फा रिमूव्ड, ग्रुप माइग्रेट्स, जो ग्रुप माइग्रेट हुआ है उसके मतलब इट इज़ नॉट इनफैक्ट माइग्रेशन, आपको पता चलेगा मैकेनिज्म जब करेंगे क्या होता है। देखिए यहाँ पर, तो पहले प्रोडक्ट लिखते हैं इसका। इन दिस केस प्रोडक्ट विल बी नाउ HOC डबल बॉन्ड O CH2 C6H5, that is product formed is acid. And now if we have taken this, in this case NH2 will come over here with CO, and hence product formed will be amide. Amide is the product formed in this case. Now again take one more example. See, we have alpha haloketone cyclic. See, if we are having a cyclic alpha haloketone, what will happen? See, we are having a cyclic alpha haloketone. Now when we are having a cyclic alpha haloketone and we are treating it with alkoxide, similar ester will be formed but with contraction of ring. Why contraction of ring takes place? Just you will come to know when we study the mechanism. जैसे मैं mechanism बताऊंगा आपको पता चल जाएगा contraction क्यों होता है. In this case again, acid can be formed. If you are treating it with this, then acid is possible. In this case, astrally possible, but with contraction of ring. So contraction of ring takes place. How contraction of ring has taken place, this you will come to know when we study the mechanism of this reaction. But let us see. This is the ester formed. Now in this case, 5-membered ring. Product formed will be ester. Okay. Now this is how we can write down the product of this reaction, base of this reaction. After this, let us come to know about the mechanism of this reaction. What is the mechanism? What are the various steps involved in this reaction? So let us start with a cyclic example of cyclic ketone. See, this is a alpha halocyclic ketone and we are treating it with an alkoxide ion in this. So what happens is alpha haloketones. So what first step is ketone, because this carbon is becoming acidic in nature, CH bond. So this alkoxide will abstract hydrogen from this. Abstract hydrogen from this means this. So here we will get negative charge species, that is a carbanion is formed. What is formed is a carbanion is formed like this. This is Cl, this is double bond O, and because one H has gone from this, so one H gone means this is getting a negative charge from this place. Okay, negative charge is getting from this place. Done. Now when it is getting a negative, you can say it is like this. This is H, alkoxide ion taking this proton, and this electron pair comes over here, and we are getting a negative charge on this. Carbanion is formed this. Now what happens? This carbanion, in this carbon, what will happen is this carbanion will attack this carbon having halide ion, and halide ion departs simultaneously. Halide ion departs. That is the next step in this, and hence now what will happen? Minus chloride ion, and after this because this has attacked this and this, a double bond O is formed. Cyclopropanion ring is formed in this case. Now see what will happen to this. Now it is very important step, and key step of this is this. You can know this will get a negative charge on this. इस पे negative charge आएगा. This carbon will get a positive charge, and this alkoxide will attack this. This alkoxide will attack this. So hence, as a result of this, species formed will be this. Here, oxygen is getting a negative charge. Oxygen is getting negative charge, and this is getting a alkoxide ion over this. अब देखिए, now ring cleavage takes place. Now for ring cleavage, let me do some numbering कर देता हूँ इसके अंदर थोड़ा सा, तो उससे बहुत अच्छी तरह क्लियर हो जाएगा. Let this be carbon number 1, 2, 3, 4, 5, and let this be carbon number 6. Now there are two possibilities. C1, C6 cleavage can take place, or C1, C2 cleavage can take place. Say C1, C2 cleavage is taking place. C1, C2 cleavage is taking place. Okay. Now if C1, C2 cleavage is taking place, what will happen? This bond will cleave, and this bond will cleave means this will get a double bond, and hence we will get a ring contraction. I am telling you how ring contraction is taken. The product formed will be now 5-membered. This bond has taken. Here you will get double bond O. It will be C double bond O, and here it's OR. This is the ester formed with a ring contraction. Now similarly, say if C1, C6 cleavage takes place. Now C1, C6 takes place, this ester formed will be at this position, C double bond O, OR. Again a ring contraction, and product formed will be this. C double bond O, OR. Now, because it was a symmetrical case, and hence both the products formed are same in this case. Both the products formed are same, whether it is C1C2 cleavage or C1C6 cleavage. Okay, now let me take the next example, and that will clear you the concept of Favorskii rearrangement. Okay, say we are having the reactant which we took the basic example, C6H5CH2 C double bond O CH2 Cl, and say halogen is at this position, C6H5. This is also alpha haloketone. Both of these are isomeric product, and we are treating both of these with OH negative. Now, as I told you, when we are treating with OH negative, product formed will be acid. Here you will get OH, here you will get another group will migrate. Now, in both these cases, whether alpha halogen is present at this position or halogen is present at this position, in both cases, the product formed will be same, and that product will be HO, C double bond O, CH2, CH2, C6, H5. Now, why it is same? Why this product formed is same? This will take when we study the mechanism. Again, I'll tell you all these steps in both these example, and you will come to know why the product formed in both these cases is same. Okay, let me change the page for this, please. Okay, both these products same formed. Why it is so? Let us take first this C6H5CH2 C double bond O CH2 Cl. Now we are treating it with alkoxide. Same mechanism I have already told you. First step will be this alpha hydrogen. This alpha hydrogen will take and form an ion, that is minus ROH, and product formed in this case will be C6H5. Here you will get negative charge. This is attached to ketone group, and this is attached to CH2. I have written it like this because what will happen? This negative charge carbon ion will attack this, and simultaneously this chloride ion will depart. Now when chloride ion departs, again a cyclic product will be formed, C6H5CH2. Same cyclopropanone ring formed in cyclic compound. This is this. Okay. Now take the another example. Then we'll come back to this. Say halogen is present at this position, CH, Cl, C double bond O, and here it is CH3. And again we are treating it with alkoxide ion, minus again it will be ROH. Now what will happen? This alkoxide will attack this position, take proton from this, and carbon ion will be formed at this position. So carbon ion formed at this position means C6H5CHCl, C double bond O, and here carbon ion is formed. Now see again what will happen. This will attack this, and this chloride ion, halide ion departs from this, and as a result of this, same intermediate is formed, same cyclopropane ring. I hope this is clear. Our reactant were different, but both these reactants are giving us the same intermediate, that is this. Now in this case again, now what will happen? It will be attacked by alkoxide ion. It will be attacked by alkoxide ion. Now as a result of this attack of alkoxide ion, it will get negative charge. Carbon will be attacked at here. So product formed will be C6H5CH2 carbon. This is attached to this. This is O negative, and this is OR. Okay. Now for better understanding, let us give the numbering. Say 1, 2, and 3. Two types of cleavage is possible. Say C1C2. C1C2. This is C1C2 cleavage takes place. Now, if this cleavage takes place, it will be C double bond O OR, and this is getting cleaved from this. So what we'll get is, here you will get C6H5CH OR. Then if simultaneously write this, if C1C3 cleavage takes place. Now if C1C3, first write down C1C3 cleavage takes. Now if C1C3 cleavage takes place, now product formed will be C6H5CH. CH, here you'll get C double bond O, OR, and because this bond has cleaved, so here you'll get the CH2 negative part. Now if this cleavage takes place, C1C2 cleavage takes place, then you will get, say, C1, I have written, okay, that is why this is C1C2C. It is C1C2 cleavage, that is why it is getting same place, C1C2 cleavage, and say here we are writing C1C3 cleavage, C1C3 cleavage. Okay, in this case, if C1C3 cleavage takes place, then we will be getting double bond O and it will be attached to this. So it will be C6H5CH will get the negative part, CH2C double bond O, OR. Done. Now if it is treated with alcohol minus alkoxide, and product formed will be C6H5 CH2 CH2 C double bond O, OR. And if it is now treated with this similar this alcohol, it will take alkoxide ion from this, and product formed will be C6H5 CH CH3 C double bond O, OR. But be sure that this intermediate formed by cleavage of C1C2 linkage is always the least stable product, and this is the product not formed, and hence this is the product formed in both these cases. In both these cases, the product formed is through this. So I hope this is this about this reaction. इस रिएक्शन के हमने क्या पढ़ा अब तक? बेस एग्जाम्पल्स हमने लिए, और साइक्लिक में वाई रिंग कॉन्ट्रैक्शन टेक्स प्लेस इन साइक्लिक, when esters are formed, acids and amides are also possible in this case. Okay, we'll continue from this application of this reaction in the next part. Keep doing your work. Thank you very much.